Good morning, good afternoon, good evening. Welcome back to this public lecture on artificial intelligence in power system optimization. Today we jump into part two, where we look at the artificial intelligence role in power system optimization. We look at the techniques and also the application of artificial intelligence. Of course, in part one, we defined the three terms that make up our topic, which is artificial intelligence, power system, and power system optimization. So, when we move further, we look at the role of artificial intelligence, some of the techniques, and also the application. Um, the role of artificial intelligence gives us a dynamic approach in that it is able to enable real-time decision making when, of course, when it comes to data sets, but of course, most importantly, it can manage large data sets. When it comes to the improvement of performance, the role of artificial intelligence will enable us with self-learning algorithms that will enable the much needed improvement in the performance of the optimization. When we come to failures, artificial intelligence based predictive maintenance can help us to actually have a reduction in failures that pertain to our power system. One other aspect that the role of artificial intelligence will have is in the automation. So, by having automation, we actually have an enhancement in the operational efficiency of our optimization. And furthermore, artificial intelligence in a dynamic approach can be able to predict the future outcomes and also handling of uncertainties. When we come to power system, there are two types of uncertainties that we have to deal with. One is called the aleatory uncertainty, and the other one is called the epistemic uncertainty. So, one, aleatory uncertainties, two, epistemic uncertainties. So, artificial intelligence will basically help us in handling of these two types of uncertainties that we can find in a power system. So, what are some of these techniques that can be used for power system optimization? So the first one in line is machine learning, followed by deep learning, artificial neural networks, reinforcement learning, genetic algorithms, fuzzy logic, and swarm intelligence. When we come to swarm intelligence, what we are looking at is basically particle swarm optimization and colon optimization. So when we look at machine learning, so machine learning basically can be used for data-driven predictive analysis. In this case, you have got machine learning algorithms that are designed to learn from historical data and predict future trends. These algorithms are very particularly useful as stated in data-driven predictive analysis. Of course, it could be load forecasting, grid fault detection, or energy management. When it comes to deep learning, of course, deep learning can be used in anomaly detection in power system. When it comes to artificial neural network, they can be applied for fault detection and load forecasting. When it comes to reinforcement learning, you can have application to demand response optimization. Genetic algorithms can be applied for optimal powerful solutions. Fuzzy logic handling uncertainty in power distribution, and of course the swarm intelligent in multi-objective optimization. So what we are saying when you look at these techniques, you see that some are inspired by the human brain, like the artificial neural networks, which are basically used to model complex and non-linear relationships. If we look at genetic algorithms, these are basically based on natural selection principles, and they can also be used to solve complex optimization problems. So when we jump further, we see that the application of artificial intelligence in power systems, you can have load detection, fault detection and diagnosis, smart grid management, renewable energy integration usage, and energy storage optimization. So in this second lecture, we have looked at artificial intelligence, the role, techniques, and application. Thank you very much, and see you in the other lecture on this topic. Thank you very much.